Speed versus circular motion. We know that the speed is a kind of a less formal definition for the velocity. In physics, we speak all the time about velocity. We discussed before, speed is the magnitude of velocity, and the velocity is the scalar value for the speed. So when we are talking about a linear system, there is somebody who's running along the street, there is a car who's driving down the highway. All of these objects are in linear motion. We can express them through velocity and speed to describe the magnitude and the direction of how fast this object is moving. When we're talking about circular motion, then in this case we're talking about circular speed. We have a disc rotating around an axis. We said that disc or that wheel or that tire is doing a circular motion. If you want to describe how fast this disc or this guy is rotating around the axis, in this case you need to use the circular speed to be able to do a good or a consistent physical representation of his velocity. In linear systems, we said velocity equals the difference in distance or displacement over the difference in time. We know that in a circular motion, going back to the object rolling around a circle, to be able to do a full rotation, the object is going around the circumference of that circle. So the law or the equation of the circumference of the circle is part of the equation that would represent the displacement of the object. In circular motion, we describe the time in a period. How long did the object take to make a full circle? So with that being said, we can say the circular speed or the circular velocity equals 2 by r, which represent the radius from the center of rotation to the point where the object is located, over the period, which is how many seconds it needs for that object to complete a full rotation. As you use v for linear speed as delta d over delta t, we use circular velocity as 2 by r over t. Now let's take an example on that. If we have a little rock that's stuck in the tread of the tire at a distance of 36 centimeters from the axle, that represents the r, then it takes just 0.4 seconds for the wheel to make one revolution. That represents the cycle t. What is the speed of that rock at any instant? Firstly, we align on the picture where is the r and what's the direction of v, and we set up the convention of directions. Right means positive, upwards means positive, left negative, and downward negative. To be more consistent, you should as well define clockwise is positive, counterclockwise is negative, but that's a more advanced topic. We will talk about more as we're moving forward in the chapter. So r is 36 centimeters. It's preferable to be able to be consistent with units, to have it in the units of meter. So you convert centimeters to meter, will give you 0.36 meters. For the cycle t equals 0.4 of a second. Seconds is a consistent unit in this case. Find the speed v. Now by using the equation of circular velocity, v equals 2 by r over t, we have r and we have t. Replace them in the equation. 2 by 0.36 over 0.4 would give you the circular motion or the circular speed for the rock stuck on the tire is equal 5.7 meters per second at any instant. If the velocity is constant in this case, then wherever you measure the speed of the rock as the tire is moving, it would be 5.7 meters per second.